The AI world is undergoing one of its most exciting and fast-paced transformations yet, and what's happening now isn't just overhyped tech buzz. It's real, tangible progress. From revolutionary training methods to smarter, self-improving models, new players are rising and established names are leveling up. One such momentous development is DeepSeek's new AI system, which introduces a novel way of teaching models to think better and even outperform big names like GPT 4.0 in certain benchmarks. Meanwhile, OpenAI is also rolling out upgrades and new models, including a powerful memory update for ChatGPT that could reshape how we interact with AI daily. Watch the whole video for complete information. DeepSeek GRM, the next step in self-improving AI. At the heart of DeepSeek's innovation is DeepSeek GRM, a system that introduces a sophisticated way for AI models to evaluate and improve themselves. This system is built on a training approach known as Self-Principled Critique Tuning, SPCT, a process that allows AI models to not just generate answers, but judge, critique, and refine those answers using internally learned principles. Here's how it works. When an AI is given multiple possible responses to a query, it doesn't just pick the best one. Instead, it first generates a short explanation or principle, a kind of rule book it's developed to judge what makes a good answer. Then, using those principles, the model critiques each potential answer, assigns a score from 1 to 10, and identifies which ones meet the criteria for correctness, clarity, safety, or other chosen values. This internal feedback loop is what allows the model to grow smarter with each evaluation. Repeated sampling and meta-filtering, smarter judgment calls. What sets DeepSeek GRM apart from typical models is its ability to perform repeated sampling at inference time. In simpler terms, instead of judging responses once, it can repeat the evaluation process multiple times, each time possibly arriving at a different judgment. By either averaging these results or using a voting system, it produces a more reliable and refined final answer. But DeepSeek didn't stop there. They added another layer of reliability through a meta-reward model called METARM, which filters out low-quality or illogical critiques. This way, the system doesn't rely on just one critique. It gathers several, discards the weak ones, and then finalizes its judgment based on the best available insights. This multi-pass filtering mechanism ensures that the final decisions made by the AI aren't just statistically sound, but qualitatively superior. SPCT, the two-phase training strategy. DeepSeek's SPCT training method is divided into two main phases. 1. Rejective fine-tuning, RRFT. This phase establishes a baseline understanding of what makes a good critique. It uses a massive dataset of 1.07 million general instruction samples, alongside 186,000 pieces of rejectively sampled data. In this approach, if a model's predicted score doesn't align with the known best responses, it's thrown out. Surprisingly, even if the model gets everything correct right away, those examples are discarded too. The idea is to focus only on challenging, thought-provoking cases that truly test the model's reasoning. In addition to multi-answer critiques, they also included single response data, labeled with binary values, 1 for correct and 0 for incorrect. The model is then trained using this curated dataset with a batch size of 1024 and a learning rate of 5e6 over 900 training steps, utilizing 128 A100 GPUs. This entire step took around 19.2 hours. 2. Rule-based online reinforcement learning, GRPO. Here, the model compares its predicted best response with the actual best one, receiving a +1 reward if correct and a -1 penalty if not. To maintain stability and avoid divergence, a KL penalty of 0.08 is also applied. This stage involved training on 237,000 data points, again over 900 steps with a batch size of 512 using the same GPU setup. It took about 15.6 hours. Model sizes, from compact to colossal DeepSeek. GRM was tested across various model sizes to gauge performance. These ranged from a 16B model using a mixture of Experts Foundation, the flagship 27B model based on Gemma 227B Massive 236B and 671B models, again using expert mixture architectures. Among these, the 27B model emerged as the sweet spot for most applications, offering the best trade-off between cost and performance. Notably, DeepSeek showed that by simply performing 32 repeated samples at inference time, the 27B model could match or nearly match the performance of the massive 671B model, which is much more expensive and resource-intensive. Benchmark performance, beating the giants. DeepSeek GRM was benchmarked against several tasks, including Reward Bench, focused on chat safety and logical reasoning, PPE, preference and correctness, RMBB, helpfulness and harmlessness, RM mistake, error detection for single responses. The 27B model scored 86.0% on Reward Bench with a single pass. Using 8-sample voting, the score jumped to 88.5%. 85%, and with MetaRM filtering, it even hit 90.4%. In other benchmarks, PPE preference improved from 64.7% to 67.2%. PPE correctness increased from 59.8% to 63.2%. The average performance across all benchmarks went from 69.12% single pass to 72.8%, 32 sample voting plus MetaRM. These numbers don't just beat existing large-scale models like Neutron 4340 BR reward, 70.5%. In some cases, they even outperform GPT 4.0's 71.3%. Challenges and trade-offs. Of course, this new approach isn't flawless. It struggles with tasks that require exact single correct answers, such as math or coding, especially when no ground truth is provided. However, when such reference data is available, DeepSeek GRM can hit over 90% accuracy in math, rivaling specialized models. Another limitation is computational cost. Repeated sampling and generating detailed critiques takes time and energy, and if the KL penalty isn't properly tuned, the model may drift off course or behave unexpectedly. Nonetheless, ablation studies confirm that crucial techniques like principal generation and rejective sampling are vital. Removing them causes performance to drop significantly. DeepSeek R2 and open source rumors. There are also rumors swirling around a new chatbot, allegedly called R2, following the success of the initial R1 release. Although DeepSeek hasn't confirmed if R2 will integrate the full GRM system, speculation is rife that it will include even more advanced self-improvement features. Moreover, DeepSeek has teased the idea of open sourcing their models, which would be a significant step forward in a world increasingly seeking transparent and accessible AI tools. No firm release dates yet, but the possibility is generating a lot of buzz.
OpenAI's big moves, GPT 4.1 and memory upgrades. While DeepSeek is making waves, OpenAI isn't standing still. The company is preparing to release a suite of new models, including the highly anticipated GPT 4.1, a refined version of their multimodal model that handles text, images, and audio in real time. Alongside this, OpenAI is expected to roll out mini and nano versions of GPT-4.1, optimized for lighter, faster applications. There's also talk of a new O3 model and an O4 mini, which may arrive even sooner. Leaks in ChatGPT's web code suggest these releases are imminent, possibly within days. But the biggest update might be to ChatGPT's memory. ChatGPT now remembers everything. ChatGPT's memory feature has received a major overhaul. It can now remember everything you've ever told it, not just a small amount of contextual data. This changes the way users interact with the AI, making conversations feel more personalized and natural, almost like talking to a real assistant that grows with you over time. Previously, memory was available only to select user tiers and was somewhat limited. Now, it's rolling out to ChatGPT Pro users, with Plus Team and Enterprise users next in line. Free users haven't received it yet, and users in certain regions, like the EU, UK, Switzerland, Norway, Iceland, and Liechtenstein, are excluded for now. Importantly, this memory feature is fully optional. You can turn it off, manage what it remembers, or use temporary chat mode where nothing is stored. Final thoughts. Smarter, not just bigger. The AI world is shifting its focus from simply building bigger models to creating ones that are smarter, more adaptive, and capable of self-improvement. DeepSeek's GRM model is a standout example, using self-critique, internal principles, and reinforcement to become more accurate without scaling up compute costs unnecessarily. And with OpenAI's latest improvements, including personalized memory and lighter model versions, the race is on to make AI more human-like, more helpful, and more integrated into our daily lives. Whether it's a bold step forward or a sign that we're getting too comfortable with AI knowing everything about us, one thing's clear: we're entering a new era of intelligent machines. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you never miss an update. Got any questions or feedback? Drop a comment below. I love hearing from you. And hey, if you're looking to take your business or brand to the next level, be sure to check out GDF Marketing, your one-stop solution for digital marketing strategies in the age of AI. Visit us at gdfmarketing.com and see how we can help you grow smarter and faster.